Good afternoon, my wonderful chemistry students. Video number 6, electron configurations. When we are done with this video, we will be able to use this periodic table to understand how many electrons there are in an atom and where do I find them. We're going to get two new vocabulary terms, kernel electrons, and much more important, valence electrons. The electron configuration of cobalt is right there. This is the information, those dashed lines, or those dashed numbers, I'm sorry, in the reference table are the electron configurations. So, how do electrons pack around the nucleus of an atom? This is a good old-fashioned Bohr diagram. We will get into that later. And you will see that the first two electrons always go in the first orbital. I made them in blue. It's not very easy to see. I will switch to red. And then I get 8 in every one after that. Okay, that's what we're going to figure out and be able to decide a little bit about how a ground state electron should be. So, electron configurations. A dash chains of numbers found in the lower left-hand corner. And when I get there, I get the number of energy levels. So we can see there's 2 energy levels in this diagram here. The first energy level has 2. The second energy level has 4. So now there's hidden information in there. You didn't know necessarily that those were energy levels, but they are. Okay, so and in each energy level, I know the number of electrons. Okay, so electron configuration of magnesium. And I look up magnesium in my handy-dandy reference table. I see it says 282. Well, magnesium with a +2 ion. Well, if I get a +2 charge, that means I lose electrons. We remember from the ions video. So notice I just lost the 2 electrons here at the end. Now I am an ion. So we got some practice with these. So bromine, Br. Let me find Br. Br says it is 2, 8, 18, 7. Okay? And it says Br with a -1 charge. So did I gain an electron or did I lose? That's the question. When I see the -1, I think I got to take away. But remember I told you in the ions notes packet, it is opposite. So in order to get a negative charge, I must have more electrons than protons. So that means I gained 1. So now the configuration would be that. I gained 1. Notice I put it on the end. Okay, barium. Barium. Where are you, barium? Find you. I see bromine very easily. I always find bromine first. Here's Ba. Barium. 2, 8, 18, 18. Back to 8, 2. And then it says lead. Lead is Pb. And there is an asterisk. Shortcut allows you to cut out the first 2 orbitals and shorten the address. So I can take out the first 2, which is of course the 2, 8, and then I'm given 18, 18. Okay, I lied. It's 1832. Getting ahead of myself. 1832, 18, 4. Okay, now it's time to dig a little deeper into what each of these numbers means. So, valence electrons. This is the word you've got to know almost the most out of this whole unit because this is going to be used for all year. Kernel, not so much, but valence, yes. They are the outermost electrons in the last number in my electron configuration. So if I get 2, 8, 7, the 7 is the outermost shell. That is my valence electrons. The kernel electrons are my inner ones, and they're a little bit more boring. And you know what? They don't really do anything as far as bonding and stuff. They just talk about our total number of, they help us figure out the total number of electrons, but they're not going to do anything. We're really concerned about that valence number of electrons. That's going to tell us how many bonds we make. Do I explode when I go into water? That kind of stuff. So we like valence electrons the most. So I see nitrogen. I'm going to practice. Let me find nitrogen. I see nitrogen is 2-5. Okay, so I have 5 valence electrons, and I have 2 kernel electrons. Okay, so let's do the next one. Sodium, Na, NaA, changing the colors. I have 2, 8, 1. Valence is my outside is 1. Everything else is my inside is my kernel, 10. Pretty easy. This part is not that difficult, but what you need to know is that valence electrons are the outermost electrons. That's the key here, guys. Okay, so now, principal energy levels. There are energy levels. We do S, P, D, F to give them names and so we know which ones we're talking about, okay? And they are the orbitals. They kind of tell us where I should find the electrons. So there's a little equation that's going to help us figure out, how many energy levels and how many electrons we have. So this is the equation, 2n squared, and I'm going to take this number 1 as my n and plug it into that equation. So it's going to be 2 times 1 squared. 1 times 1 is 1 times 2 is 2. So there'll be 2 electrons in my first principal energy level. Now, in my second principal energy level, I'm going to put a 2 in there for n. So it's 2 times 2 squared. Well, 2 squared is 4. 2 times 4 is 8. I get 8 valence electrons in my second principal energy level. And we just keep doing this. In my third principal energy level, I'm going to get 18. 2 times 3 squared. 3 squared is 9. 2 times 9 is 18. I'll have a total of 18 in my third principal energy level. So, practice for you to do. Electron configurations of oxygen. We have to do that right off the reference table. This is an ion, so I got to change. Do I gain or lose an electron if I form a positive? I lose 1. I'll give you a hint. I lose 1 electron. How many valence are there on the end of fluorine? So look up F for fluorine, and it's the last number. Again, valence, last number. Okay, kernel. Kernel is my inner one, so add all the ones up that isn't my last number. And then principal energy levels, I have to use that little equation we just did. So you do the practice, and we will check in class. Now we can identify valence and kernel electrons. We can calculate principal energy levels. And with a little bit of practice, you guys are going to have this without a